Let me just make sure my microphone works. Let me make sure the clicker works. There we go. Yeah, hi everyone. Thanks for having me. I'm Mike Mahoney. I'm with the Water Data for the Nation team in USGS's Water Mission Area. Here to highlight some of the recent advances from USGS Water. I'm really happy to be following Ed because a lot of things I'm talking about are part of that next generation water observing system that I was talking about and our push to expand how we can observe and monitor the state of our nation's water resources. Now, when folks think about water at the USGS, they usually are thinking about the observational network. And for good reason. We have more than 1,000 hydrologic technicians gathering data at tens of thousands of locations, collecting a total of 100 billion observations of water data per year. But I want to start by talking about some of the research and development work that we've been doing to try and expand on this network to improve how we're able to monitor and predict the state of our nation's water resources. And to that end, the USGS is engaged in a lot of new cutting-edge activities, like, for instance, our collaboration with NASA, the Canadian Space Agency, UK Space Agency, and French Spatial Agency on the Surface Water Ocean Topography Satellite, or SWOT mission. Now, SWOT is gathering this really comprehensive spatially continuous data set of stream and lake elevations, covering about 90% of Earth's surface. It's a really fantastic data set that gives us insight into water conditions at a huge number of locations that have never been manually measured before. What the USGS is then able to do is take data from SWOT and estimate things like discharge on those remote reaches that we aren't able to reach with our traditional monitoring methods in order to improve our ability to, for instance, up here in Alaska, predict and understand major events like flooding that are starting up in these headwaters that we can't reach with our traditional methods. This is a screenshot from our Water Information from Space application, which publishes data from SWOT along with those predicted discharge estimates. And we're able to use this to give folks a much better understanding of the conditions that are likely going to be coming down to them in the future. Now, a little bit closer to home, the USGS has also been working to expand our stream camera network. These are cameras taking images at a regular basis, co-located with our monitoring locations. And these can be a really useful tool to build an understanding of what's actually happening at a given location. We make the images available through a few different applications, including our National Water Dashboard here, as well as the HiViz application, which will pair these time series of images with their corresponding hydrographs so that you can build an understanding of what a given stage, what a given discharge level actually looks like in the context of a site. These images can be really useful to help build that qualitative understanding, especially around major events. This, for instance, is a time-lapse of images from the atmospheric river in Washington last December, where having these images makes it a lot more immediately obvious what's actually happening at a location during these extreme situations. These cameras are also really useful for us operationally because we can use these cameras to detect from an office whether a channel has shifted or if there's an impediment that requires a tech going out to service a site. By having these cameras available to us, we're able to really optimize our network operations, making sure that we're continuing to provide the most accurate, up-to-date information possible. In addition to these sort of more qualitative uses, we're also working on expanding the quantitative applications of these images. You can see some of this work through our Flow Photo Explorer application, which takes these images and uses them to estimate things like gauge height, like discharge, from the image time series directly. By doing this, we're able to expand what types of locations we can do monitoring at, allowing us to make these sort of predictions at locations that might be too difficult for us to observe through traditional methods. This application will let you see what models are actually being run on these images, as well as predictions from those models and model diagnostics, so you can actually see how well the models are performing at locations that you're interested in. Now, the Flow Photo Explorer is in a category of what we call our operational modeling applications. These are the systems that have online models that are continually ingesting new data and putting out new predictions. Our most recent addition to this collection is our River Droughtcast application that will show you areas that are currently in streamflow drought across the United States, as well as our best forecast for what areas will be in streamflow drought over the span of the next 90 days. This can be a really useful early warning tool, letting folks know what situations are likely coming down the pipe for their neck of the woods. Now, so far, everything I've been highlighting is work that's being done at the national level for the USGS over the last year or so. But I also want to mention that we have a presence in every state in the country, and we are very actively working with state and local governments and private organizations to try and do the monitoring and the research that matters to manage local water resources. And so, to use an example from where we are here this week, and apologies as an interloper from the Northeast if I get any of the details wrong on this one, But talking with folks at our Utah Water Science Center, they told me a really interesting story about the work they're doing on the Great Salt Lake here. For anyone who's not familiar with the system, the Great Salt Lake is bisected by a causeway that blocks almost all exchange between the northern and southern arms of the lake, which causes them to have very different profiles. The northern arm of the lake has much higher salinity, it's an ecological dead zone, while the southern arm of the lake has a vibrant ecosystem in it, including a large brine shrimp population that, in addition to being a core food source for bird populations in the area, is the backbone of a $60 million a year brine shrimp harvesting industry. Something I didn't know before talking with the folks at the Utah Water Science Center is that if you think about farmed fish and aquaculture generally, about half of fish farmed globally, the diets of these fish is largely built on brine shrimp, and about half of the brine shrimp used in aquaculture globally comes from the Great Salt Lake originally. So it's a really core part of the global food chain as well. Now, a challenge is that because the water in the northern arm of the lake is so much more dense because of that higher salinity level, you get density-driven flow from the northern arm of the lake into the southern arm of the lake, raising salinity levels and threatening the local ecosystem as well as that industry. And so the USGS has been working with the state of Utah to monitor exchange between the arms of the lake, as well as the salinity levels in the southern arm, so that the state can manage that ecosystem. Back in 2022, the state actually went and raised a breach in the causeway to limit the exchange between the northern and southern arms in order to try and preserve the ecosystem in this area. Now, I'm picking this example because we are here in Salt Lake City, but we have stories like this anywhere that you go in the country, where the USGS is engaging with local water managers to try and give folks the information that they need to make the decisions they need to about their resources. And of course, all of that work is building off of the success of that core observational data network to bring things full circle. The National Water Information System, NWIS, is that system that's collecting those 100 billion observations per year, running them through quality assurance checks, and then making that data publicly available to everyone for free. In a given year, we have about 65 billion hits to download data from NWIS, winds up being about 70 terabytes of data going out the door, which if you think about our data where it's these small point observations, that's a huge number of observations, and about 10.5 million users use this system in a given year. If you're in that 10.5, you know it's been a big year for updates to how you access data from the USGS. In particular, this year we've retired the majority of our legacy NWIS web system, replacing it with our new modernized Water Data for the Nation interface. If you go to waterdata.usgs.gov, you'll find this homepage that introduces Water Data for the Nation, and then hopefully links you to some of the new tools that are available for discovering and accessing USGS data. Those tools include things like Explore USGS Water Data, our tool for discovering sites that are in a given area of interest, and then you can filter down to sites that are collecting just the types of data that you're interested in, that observe the parameters you're interested in for the time periods that you're interested in. You can then build a list of those sites and go check the most recent observations on them, or navigate to the modern location pages for any of those sites, which is the new centralized home for the data that's being collected at a given location. Now, by default, when you load these pages, you get the continuous hydrographs of sensor data, but we've been expanding what's available through these pages over the span of the last year, so that you can now find our daily values aggregating the sensor measurements, series of field measurements, and more, all through this one centralized home for our data. These sites also allow you to download the data that's on that graph in CSV format. If you're looking to download data from more than just one site at a time, we also now have a combined download form at api.waterdata.usgs.gov/download that'll let you download data for a few hundred sites in one form submission. You get it back as a zip folder with a bunch of CSV files. This is our general approach for non-programming folks who are looking to download large swaths of data for Excel-based workflows. For this room, though, probably more interesting is our new set of water data APIs at api.waterdata.usgs.gov. I'm running this project to release these and maintain them, so I could talk about this all day, but I'm going to try and just keep to the highlights. These APIs are the new system that's publishing USGS water data to the web for the first time. They are superseding and replacing our legacy water services system, which will be retired this coming winter. Now, all USGS water data applications are getting their data from these new APIs. And if you see a data point anywhere on Water Data for the Nation, you can download that exact same data through these tools. This is a huge change from NWIS Web, where a lot of data required actual web scraping. There was no programmatic access built in. You now have the exact same access to our data through these programmatic tools as our website does. Additionally, these new APIs are implementing standards from the Open Geospatial Consortium, specifically OGC API features. What that means for you as a user is that they're a lot easier to get started with than water services could be, and there's a lot of tooling out there that knows how to work with these APIs right out of the box. You can query these APIs using GDAL, you can load the responses in GeoPandas in SF, or you can add them as feature layers to a GIS to access our data with just about no programming required. This is a huge expansion of who can actually access data from these systems, and we are really excited that this is now something that's available to our user base. We're also focusing on making a lot of other usability improvements across the board that I think collectively add up to be a big deal. To just mention a few of them, we now publish JSON schema files that document what's actually getting returned by any of our endpoints in this structured, standardized format. Having the data types and definitions for each of those fields available can be really useful, but also means that if you are working with like agentic workflows, you now have this standardized file format that you can feed to your agent so it understands what data is actually coming back from these endpoints. We're also publishing things like time series metadata as top-level collections, meaning that you can now query the actual collections that we have rather than having to indirectly go through monitoring locations to find the data you're interested in. This lets you search, for instance, discharge collections that span your 30-year period of interest, rather than having to search for sites of a given type that were active in that time period, making a lot of common workflows a lot more straightforward. Now, these APIs are currently in their transition phase. As I mentioned, USGS has shifted entirely over to using these new APIs, and we've been doing a lot of work to move all of our partners over as we are able, including specifically Weather Service, Bureau of Rec, Army Corps. We're really trying to make sure that we move as many folks with us off water services over to these new APIs. And a major focus of mine is doing one-on-one support with folks who are emailing our helpline, making sure that as many people can migrate off of water services over to the new APIs before we decommission water services this coming winter. These days, these new APIs are handling up to about 7 million hits per day. Generally, it's more traffic than the legacy applications. And we're really hoping to get that up and up before we, again, decommission water services as part of our final decommission push for the remaining pieces of Endless Web. This coming winter, we'll be decommissioning all of the remaining legacy services that are still online. That includes water services, the legacy ratings depot, the Peak service. Both of those are now part of the new APIs, as well as things like our UV page and NWIS mapper for folks who are familiar. At that point, Water Data for the Nation applications will be the only place to access data from the National Water Information System. And we're really excited to reach that milestone because it means we're going to be able to turn our focus towards the future, towards expanding and improving the offerings that we make available. To just touch on a few of the directions that things are going in the immediate future, the USGS is currently working towards this idea of publishing what we call fit-for-purpose data. As I was talking about earlier, we have a lot of really exciting initiatives around satellite observations, around estimating parameters from imagery that can really expand the spatial comprehensiveness of our observational network, but might have higher uncertainties or might have certain characteristics that make them less desirable than our traditional collections. We want to publish that data as part of Water Data for the Nation, but we need to make sure that we're providing users with the information they need to determine if the data is fit for their applications. As such, we're moving towards publishing way more metadata about how we collect our data. Things like the methods that are being used with citation information and eventually measurement uncertainties are coming to Water Data for the Nation so that you can get an understanding of if the data is going to be suitable for your application. We're also moving towards categorizing data collections as being either experimental, limited use, standardized, or operational, so that you have this information about how the USGS views this data as being used in the future. And then last but not least, as with the rest of the federal government, the USGS is very interested in AI enablement these days. This is a very fast developing area for us that we have a lot of folks working on in a lot of different directions. To just touch on a few of them, we're engaged with ESIP, the Federation for Earth Science Information Partners, and their AI Data Readiness Cluster, making sure that we are publishing our data in these AI-ready formats that are going to be easy to ingest into machine learning AI workflows and come with the metadata necessary for them to be picked up by agentic use as well. We're also working on optimizing our services for answer engines and generative engines so that as providers like Google shift more and more towards chat-based interfaces, they're still going to be able to find the best data, the most recent, the most responsive data for the questions that you're asking. And then last but not least, we're moving towards publishing things like agent skills or MCP servers to try and make it so that we can help folks bootstrap their applications as they're working with agentic workflows so that they can quickly get the data that they're interested in from our systems and perhaps even bootstrap some of the domain knowledge necessary to actually apply that data as a next step. Again, this is a really fast-moving area for us, but I'm excited for a lot of this stuff to start coming online in the next few months. And with that, I want to say thank you all so much for having me. It's been a really exciting time for the USGS, and I really appreciate this opportunity to share some of the progress that's being made. Thank you so much.